Okay, so what I want to talk about today is I want to talk about the skateboard wall, Newton's third law problem that we encountered the other day. Okay, so one of the questions I had was basically, we get somebody who's on a skateboard. Let's dish that a little bit down so you guys can see that. So you get somebody who's standing on a skateboard, right? And what they do is they go up to a wall just like I have here, and they push against the wall. I'm just going to adjust that a little bit more just so you can see both me and the board. Okay, hopefully that's okay. So I'm on the board, and the idea is I push against this flat wall. Okay, so I'm clearly exerting a force because I'm pushing in with my hand here, right? What we have to consider though is Newton's third law. Every action there is equal, and remember that bit we sometimes forget, opposite reaction. So when I push on the wall is going to push exactly the same amount back. Okay, so if I push on the wall, the wall pushes back the same amount, equal and opposite, right? Which is why it sends both me and the skateboard that way. Okay, when I do that when I'm not on the skateboard, I don't move. The reason I don't move is because I'm not on wheels. Yeah, I'm more fixed to the ground. But when I'm up on here, if I put in a force, I'm going to get that equal and opposite force. Now, if I put in a much bigger force, right, I'm going to get a bigger force back. So I'm going to move, I'm going to accelerate more, right? Now, if I put in a really small force, I put in a tiny amount, right? I'm not going to move. The wall's still giving me an equal and opposite force, but it's not enough to make me move. The reason it's not enough to make me move is because we still have to overcome the friction on the ground. Yeah, the wheels on the bottom of my trucks here, yeah, they have to overcome the friction of the ground to actually move. So I can be there and be putting in a force and receiving that Newton's third force back, receiving that equal and opposite force, but it's not enough. I have to put in enough to overcome the friction. And the friction's, of course, the reason why I do eventually stop as well. I eventually stop because that friction is acting as a resistive force and slowing me down. Now, something to actually bear in mind a little bit here. Okay, something to bear in mind a little bit here because it sometimes gets people confused, right? You need to note that the action reaction pairs, so the action of me pushing on the door and the door pushing back at me, yeah, they're actually affecting the motion of different objects. Yeah, I'm pushing into the wall's pushing back, but then that's really carrying on through the skateboard itself, right? Something that you need to keep in mind is because if they were all acting on the same objects, then everything would just cancel out, wouldn't it? I push on the wall pushes back on me at the same magnitude, except in opposite direction. They just cancel out, and you get a net force of zero. Now that clearly isn't true because we observe that things move in this world. At least I hope you do. So what you need to bear in mind is, although the action reaction forces may cancel, the net force resulting from all the different interactions that are going on allows for movement relative to the ground, of course, because we're always moving because we're spinning around in space in multiple directions, right? That's just a little explanation for now to explain why things actually move, because you might be going, wait a minute, everything's just cancelling out. And that may happen, but the net force resulting from loads of different interactions that are going on allow for movement. That's because the action reaction pairs are affecting the motion of different objects. If that doesn't settle right in your brain so far, don't worry about it because it's something you'll focus on more when you go further and further into your physics course. If you are interested in that, this is explained by a classic problem called the horse and cart problem. So if you want to look up the horse and cart problem, and I'll put a link to actually that in the description below. It's a classic physics problem. It works through some of these ideas. But as I said, right now we don't need to worry about that. I just want an excuse to hop on my skateboard and show you some of this Newton third in action. Okay?